Welcome to Unit 5, Lesson 2, Representations of Growth and Decay, Practice Problems. All right, a home is purchased for $170,000. Since then, its value has increased 5% per year. Okay, so let's talk about what we are given here. So, 170,000 is your A. That is 100%. Your value is 100%, which is $170,000. Now, it increased 5% per year, so that means plus 5%. Your increased percentage is not a growth rate. You have to take the original amount and add 5% to it to write a proper exponential equation. So our proper exponential equation is going to be, I don't know, home as a function of time is our start amount, our growth rate, that's $170,000, is 105% over 100 to the t power, where t stands for time, but we usually use x because you put x into the calculator. So 105 divided by 100 is 1.05. 1.5, this is our actual growth rate. So the proper equation, h of x, t stands for time, x stands for x, per year. That's how I know it went with that, because it was next to the year, where our x stands for years, 1.05 to the x. You can write it with a t, you can write whatever variables you want to write. Doesn't make a difference, but write the proper thing. See how the b is greater than 1? If we would have used 170,000 to the 0.05, this b is less than 1. You're telling me that the home loses 95% of its value. You know, you'd have gave me $170,000 house in year one. It'd be worth like, what's 10% of 170, 85,000, half of 85. So if you'd have put that in the calculator, at year one, it'd be worth $42,000. And that's not what homes do. They increase in value unless you destroy it somehow or live in a bad weather spot. Okay, what was the value of the home 3 years after it was purchased? Well, 3 years after it was purchased, since we put the proper equation into the calculator, when x equals 3, y equals 196, 796. All right, write an equation and function notation. We already did that. So I don't like how they ask you to calculate something first and then write the equation. Write the equation first. Now, will the value of the home be worth more than 500,000 30 years? So all you have to do now is scroll down to when x is 30. So when you scroll down when the x is 30, the value of the house will be y is 734, 730. Plus some change, but we're going to round it off to that. So this is way more than $500,000. This is what makes homes good investments, because they will increase in value. Maybe by not 5%, but they will increase in value. Okay, looking at problem 2. Now, we have a graph. We don't have any numbers, but now we're going to have to extrapolate numbers off the graph. So the first thing we do is find 0. This is our A. How do I know? When x equals 0, our starting point is at 100. So 0, 100, which is also called your B in slope-intercept form. So from Algebra 1, it's your B, it's your start point. The next thing you have to look for is where the curve goes through the corner of a box. The line must go through the corner of a box. And at 120, we now have 2 points. Now we can calculate our B. So in exponential functions, you have to multiply continuously to get to the next point. So if you multiply going right, you have to divide going left. And that's exactly what we're going to do. So we're going to take 120, we're going to divide it by 100. That's going to give us 1.2. This is our growth rate because we had 100 foxes in year 0. That's where we started. By year 1, there were 120. What's this? Wolves, not foxes. Okay, so now let's write an equation. Y equals 100, 1.2 to the x, and this is years. X stands for years. The input and the output is wolves, and the x is years. The population when it's first measured was 100. The growth factor is 1.2. We already wrote the equation on a previous page. Y equals, or f of t equals, or w of t. All right, let's use what they use. W of t to right function notation is 100, 1.2 to the t power. And if we have to calculate, make sure you use x's because the calculator will not recognize t's for variables. Okay, here is no explanation on the graph. They just said, find an equation of f, explain your reasoning. So this may be accurate, this may not be accurate, but let's see. I would say this is about half of the first line. If this is 200, this line must be 100. And if this is half, this must be 50. So 50 is our start, 0, 50. When x is 0, y is 50. Look where the line goes to the corner of the box. You can choose this point or this point. But since that's 3 jumps, it's not one whole jump, I'm not going to use 3. Because you got to divide it 3 times, and I'm not trying to do that. Make it easy on yourself. Okay, so at 1, it looks like it goes to the corner of the box. At 1, we're at 100. So 100 divided by 50 is about 2. So it looks like this is our growth rate. So to write an equation, f of x is equal to our start, 50. Our growth rate is 2, or is doubling, to the x power. And we don't know what x is because we don't have any information on the graph. This is as reasonable a solution as I can give you. Okay, so let's look at this. We have an equation. Our car started off at $24,500. It is worth 88% of its original value each year. Each year is worth after it was purchased. So, what is our question here? What does the number 24,500 mean? 24,500 is our A, is original price of the car at year 0, or when we bought it. 0.88 is what the car is worth. Is what the car is worth. Because if 24,500 represents 100% and it lost 88%, we're left with 12. 12% is the depreciation value. F of 9. 9 is an input number. 9 represents 9 years. So F of 9 will give us what the car is worth 9 years. In 9 years, the car is worth some dollar amount. We don't know. We could calculate it, but they're not asking us to calculate it. Sketch a graph that represents the function. Now, you can always sketch a graph. So we start at 24,500, and exponentials curve down. without putting numbers, without looking at numbers, that's what it's going to look like. Now, you're not going to see this on the graph, and we got to talk about changing windows, but I'm not worried about graphs just yet. We will come to graphs later on in the unit. Okay, exponential sequence are the same as geometrical. To get from one term to one term, we have to multiply or divide. So to get from 18 to 6, you got to divide by 3 or multiply by 1/3. So we want the next three terms. 8 divided by 3 is 6. Divide by 3 is 2. Divide by 3 is 2/3. Divide by 3 is 2/9. So 18 times 1/3 equals 18 over 3, which is 6. 6 times 1/3 equals 6 over 3, which is 2. 2 times 1/3 is 2/3. Because when we multiply a whole number to a fraction, we put the whole number over 1. Any number can be divided by 1. It's the same number. Then we multiply fractions. Tops multiply tops, and bottoms multiply bottoms. 2/3 times 1/3 is 2/9. Is that 3 next terms? Yeah, 1, 2, 3. Okay, there we go. A bacteria population has been doubling each day. Here's the B right here. How do I know? It's next to each, and our X stands for days. For the last 5 days, it is currently $100,000. What was the bacteria 5 days ago? So this is like the pond problem from before. So if we start at 100,000 and we double, we're going to go forward. But what's the opposite of doubling? So you take times 2 and you flip it upside down. That little funny looking symbol means to flip it upside down. So you times it by 1/2. You're still multiplying. So if we go by 1/2 to the X, which stands for days, we're going to go backwards. So put this into the calculator, and then when X equals 5, because day 0 was 100,000, what's Y? When X is 5, Y is 31.25. Wait, what is that? Is that point? No, that's not 0.25. I'm sorry. That's 31.25. And you're going to do the same thing when you put these numbers into the calculator. You should get the same thing. Okay, select all expressions that are equivalent to 27 to the 1/3. Remember how to change a fraction exponent into a radical. So we have the cube root. We have the cube root of 27, which equals 3. I can also write this as a lot. So 27 is 3 cubed to the 1/3 power. Okay. So B works, D works. The cube root of 3 cubed, that works. And the exponent is not negative, so A doesn't work, C doesn't work, that's square root, F and G don't work.